The next question asks, which is the only type of function below that has an asymptote when graphed? All right, if you look at these visuals I gave you right here, I think you can see clearly that this is the only one that has an asymptote. It's an imaginary line that the function never crosses, but gets closer and closer to the further it goes towards one of the infinities. And so in this example, that's called an exponential function. All right, which is the only type of graph below that could have a local maximum? All right, well, this is an example of a quadratic that has a local min. If you flipped it upside down, it would have a local maximum. So quadratics have, of these three functions, it's the only one that would have a local max or local min, so it's a quadratic function. All right, we already discussed that this is a shape of an exponential function, so the name of this is exponential. And then it asks, as x moves towards negative infinity, this is the only time we're going to ever move left on a graph, but it means as x goes to the left. So as I go to the left, I'm going to the left on this graph. What does this level out on for the y? It's leveling out on negative 3. And as x goes towards positive infinity, which that means as x goes towards the right, so that means I'm moving from left to right on this one. So as I move from left to right, it's going up towards forever. And so it's just going up towards a positive infinity. If it goes up towards the sky, it's infinity. If it goes to the floor, it's negative infinity. But so to the right, it goes to positive infinity. And to the left, it levels out on negative 3. All right, the next graph is called a quadratic. The shape is known as a parabola. But if you look at this one carefully, as x moves to the left, that means, all right, this is the one time I'm moving left to right when I'm going towards negative infinity on the x, so I move to the left. As I go left to right, as I fall off the graph from left to right, it's going upward forever, so it's going up towards positive infinity. All right, let's try the other direction. As x goes to the right, that's what that one says, is it goes towards positive infinity. So that means to the right. So as I go from left to right, you can see I'm moving across the graph left to right. Again, it's still going up. I'm talking about the y value is going up towards positive infinity. All right, so you can see on the asymptotes, you'll have one of the two sides most likely level out towards an asymptote, and the other side will go to infinity or negative infinity. With quadratics, they'll both either go up or they'll both go down, which would be negative infinity. So let's write down what these actually mean too. So on the right-hand side, we're talking about up and down, so that moves up. And on this one, since it's positive infinity, it was moving up. And on that one says positive infinity, it was also moving up. So basically, as we go to the left, it goes to negative 3, but as we go to the right, it goes up on this one. And on the quadratic, as we go left, it goes up, and as we go right, it goes up. Well, let's try the last one, the linear. So this last one would be a linear function. And again, it says as x goes to the left, whenever it approaches negative infinity, we're talking about going left. So as I move left to right, starting from kind of the center of this graph, as I move left to right, although it's moving slow, it's continually moving down towards negative infinity. It's moving down. So that would be towards negative infinity because it keeps moving downward. And then as x moves, well, let's write down, since it went to negative infinity, that would mean that this says as it moves to the left, it moves down. And again, it says as x is going towards positive infinity, that means to the right. If we follow this graph to the right, it continues to go up forever. So if I keep going upward forever, that's going towards positive infinity, which is up. So it's basically just describing the ends of the graph. So we're saying as it goes left, it goes to negative 3. As it goes right, it goes up here. Here we're saying as it goes left, it goes up, and as it goes right, it goes up. Here we say as it left, it goes down, and here as it goes to the right, it goes up. For these next ones, let's use the functions you looked at to help us answer these questions. This is which is the only function, I'm not sure if it's the only function, but that might have an end behavior that as x approaches infinity, f of x approaches 4. So as x approaches infinity, that means as x goes to the right, that f of x approaches 4. Well, if I look at the choices up here, there was only one graph that actually, at least using just the examples that are up here, there's only one graph that actually had f of x approach a number. I mean, if you looked at all the other examples that we had infinity, 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 there's only one that actually approached a number. So they probably intended for this problem to be an exponential function, but I think there's actually possibly two answers. So exponential is probably the most likely because every single time you draw an exponential, one side goes towards infinity or negative infinity, and the other side levels out on a number. So exponential is probably a great answer. But there is a type of function that does level out sometimes that also could level out. Now quadratics can't. They'll either both go up or both go down. You see up here, both these went up, or you could have it upside down and they both go down at the ends. But there's a special type of linear function that might fit that criteria as well. If I drew a axes, so let's say this is the xy axis, 1, 2, 3, and then I drew it to 4. There is one type of line that won't go to up, one side won't go up to infinity or negative infinity, they won't go opposites. If you just had a line that was level, right at 4, that was totally horizontal with a slope of 0, technically as that approaches to the right, it does approach 4 still. So it could also be a linear function, but I'm going to do that lighter because that's more unlikely, because there's only one specific type of linear function that would do that, whereas there's an infinite number of exponential functions that approach 4. So maybe it's not best to say the only in this one. All right, which is the only function below that might have an end behavior such that as x goes to the left, let's write that down, as x goes left, the function goes up, and as x goes towards positive infinity, which means to the right, as it moves towards the right, it also goes up. Now if you look at this, the lines either go level out on the same side and they'd be the same number twice, or one goes towards infinity and one goes towards negative infinity. Exponentials always have a value and infinity. The only one that has both of the same end behaviors, these both go up or both go down, is a quadratic function. So the only one that would fit that end behavior description would be quadratic. Which is the only function below that might have end behavior such that as x approaches left, or negative infinity, f of x approaches negative infinity, and as x approaches infinity, f of x approaches positive infinity. Right, so let's write this down again in terms of left and right, up and down. All right, so this again says left. As x goes to the left, this goes down. And this one says as x goes to the right, from left to right, it goes up. Now the only one that switches infinities up here, if you look at this example that we had up here, is the last one. This one goes basically to negative infinity, and then on the other side it goes to positive infinity. So because it switches like this, the most likely case for this one is going to be linear. Alright, one more. It says, which is the only function below that might have end behavior such that as x goes towards negative infinity, f of x goes towards negative infinity. So let's write that down again, what that represents. That means as it goes left, this goes down, because towards negative infinity. And then this says as x goes to positive infinity, that's to the right, x also goes down. So I think that would also be the only one that has the same two, is if we had a parabola that's upside down. Both of the ends are pointing downward, so that's going to be quadratic again. So let's kind of draw all the pictures. So we said this was quadratic right here because it probably went up to, both sides went up. And we said this was a line because, well, one side went down to the left, the other side went up to the right. And we said this one could have two possible answers because it's basically could be exponential decay, where it levels out on 4. Or we could have a line that goes straight across like that. So those are the examples. They just take a little thought, and you have to think through and draw some of them sometimes. But please don't hesitate to ask your teacher if you have additional questions on these. And I'll start the next video in just a moment.